Hello, everyone. In this video lecture, we will be learning about 8279 keyboard display controller. So, which is a topic in your fourth module. So, and we are also seeing about the different type of chip that helps you to interface your input with your output device. So, first, an introduction to this 8279 keyboard display controller. So we see that 8279, this is a chip that was created by Intel, and it is a programmable peripheral PC. Okay, so, and its ultimate responsibility is to interface your keyboard, that is with your input device, with your display system. So mainly it helps you to provide the support for the microprocessor like 8085 and 8086. So, and it also helps to simplify the input-output operations. So how it helps to simplify the input-output operation based upon these important functionalities. So first, it helps you to do a keyboard scanning. Okay, so to do a keyboard scanning is to take a specific input from the user, and the second important feature is key debouncing. So normally when the user is pressing a key on a keyboard, the switch, it does not give the signal immediately. Okay, so a lot of bounces that takes place for a few milliseconds. So there is a multiple on and off. Okay, so how to avoid all these noise, and how we are able to fetch a clear input that is provided by the user. And the third important feature is display refreshing. Okay, so how the user is able to see a continuous update on the display system. So for this 8279, it acts as an intermediate device. So between the CPU and the external devices like the keyboard and the display device. And what are all the important functions? Okay, so first and the foremost thing is this automatically scans the keyboard matrix. So the input is assumed to be a matrix which comprises of rows and columns. So whenever a user is pressing a key, the input is detected based upon the row and the column that is given as an input by the user. And the second important functionality, it stores the data in the memory. Okay, so it stores the data in the buffer, and the buffer will be in the form of first in, first story. Okay, so it operates in the form of a queue. So therefore, there will not be any glitches. So whatever the input that is provided first will be processed first. And the LED display. Okay, so which is a 7-segment display. So to display all the inputs from 0 to 9. So 0 means what are all the segments like A, F, E, and then D, G, B. Okay, so these segments will be activated. So this helps to refresh the display without the involvement of the CPU. So how the LED is able to have a continuous display and with the help of this flickering on and off. So apart from this, what are all the most important features? So first is 8279, and it's a programmable device. So that helps to interface the keyboard and the output with the microprocessor. So, and already I told that to get the keyboard scanning, to get the input from the user, and the second one to control the display. And it includes four important features. 8279 can interface with a matrix. Okay, so let us assume that keyboard is a matrix which comprises of 8 cross 8, totally 64 keys. So and already I told that it uses the row and the column scanning. So mainly to fetch, to detect what is the key that is provided as an input. So this reduces the number of required input lines. So instead of using 64 separate lines, so we need to have only 8 rows and 8 columns, which is equal to 16 lines. So using that, we'll be able to, the chip will be able to get the input that is provided by the user. And the second important thing is like it has the feature of an automatic and key debounce. Okay, so I told, so whenever a key is pressed, okay, so not a one signal will be activated, multiple signals will be activated and lot of noise will be there. So this will be able to automatically filter these unwanted signals. This ensures that only a valid key is pressed. Okay, so this helps to avoid any overload within the CPU, and it helps to improve the reliability of the system. Okay, so and the third important thing is the most important feature, and how it is able to control the display system using the 7-segment display. And it activates one display at a time very quickly, and that creates an illusion that all is on. Okay, so this helps mainly to reduce the number of output lines, and also it helps to reduce the hardware. So that way we see that it helps to reduce the wirings, and it saves the hardware and saves the power. And the next is the buffer. I told it is first and first store. So 8279 will store the key press that is provided by the user in the form of a queue. So therefore, even if the CPU is received in processing some of the input, it ensures that the keys are processed. Okay, so in the same order, the input has been given. Okay, so that is first step, first step. So this is the diagrammatic representation for 8279, okay, so which includes the pins that is DB0, DB7, that is the data bus pins, okay, and RL, this is the return line, okay, and SL, it is the scan line, and A0 to A3 and B0 to B3, these are all the output signals, okay, and then we have chip select, and we have the interrupt request signal. So, and the clock is mainly to sequence the operation according to the timing signal. So these are all some of the input pins of this particular chip. So now here is a clear description. So what does this pins represent? So first and the foremost thing, it is to transfer the data, okay, or the information between the processor and the chip. So in order to transfer the data and the information between the processor and the chip, we have the data bus, and we have the pins which is numbered from DB0 to DB7. And we have this active low of CS, okay, which means the chip select. So it is the one that helps you to want to activate 8279 chip. And then active low, that is some read signal, okay, and active low of write. This helps to ensure that the data is read from the chip, and active low of this WR, this is the one that helps to make sure that the CPU writes data or commands into the 8279 chip. And where we have this address line, which is A0, is the address line. Okay, so that is the one that will be able to select the control or data register. Okay, so and clock is the clock signal that provides the timing signal to synchronize the operations and events according to the timing signals. And reset is the one that helps you to initialize the device. And we have the RL, that is the return lines, okay, and SL not, they are the scan lines. So these are all the pins of the keyboard, and RL not to RL7. Okay, so these are all the input lines mainly they are connected to the rows. Okay, so mainly to get the input, which key is pressed by the user. And SL0 to SL3, these are all the output lines that is connected to the columns. Okay, that helps to activate a column one by one to scan the keys. Okay, because one row, activating a row and a column corresponds to the key pressed by the user. Okay, and both together forms the keyboard matrix. Okay, and RL naught, they are the return lines, SL naught, they are the scan lines. So now the display section pins, mainly it helps you to display the data in a 7-segment file. So the output from A0 to A3, that helps to display the output A, and then from B0 to B3, that helps to display the output B. Okay, so this controls which segment is flown to make sure that the output or the numbers is shown. And apart from that, we have the special pins. Okay, so that is we have VD, that is blank pins, that turns off the display temporarily. Okay, and our IRQ, it is the interrupt request. It is the one that helps to signal the CPU that when a key is pressed. Okay, and apart from that, we have the pins like the control and stroke. Okay, so mainly it helps you to detect whether a control key is pressed, okay, or an alter key is pressed, okay, or a strobe signal that gives an indication that a data is read. So that is the diagram, that is the pin diagram. What you are looking at that now, it is the block diagram. So we have the different components. Okay, we have data buffers, we have IO control that includes the pins like the chips like write, read, and the first in, first out, okay, and then the address register and the RAM, okay, and the timing and control registers. So the data buffers, it is the one that provides the interface between CPU and 8279. Mainly, it is the one that helps you to want to transfer the data between the CPU and 8279. Okay, so it is the one that you need to hold the data temporarily for some time. And then I input output control. This controls the read-write operation. Okay, so IO control, it includes the signals like A0, the address pin, okay, and then chip select, and then active low, that is the write operation, an active low of read, which performs the read operation. Okay, and then we have the control and the timing registers. Okay, that helps to store the control words. And also it defines the operating modes. And then we have timing and control that synchronizes all the operations using the clock signals. Okay, it controls the keyboard scanning, okay, and display refresh. And apart from that, we have the scan lines, that is SL0, okay, and till SL7. Okay, so this is mainly used to scan the inputs, okay, and also we have this keyboard debounce, okay, that this is the block that helps one to remove the noise whenever a key is pressed, and it detects a valid key is pressed, okay, and it controls the keyboard interface. And we have FIFO, okay, a random access memory, and that stores the key press data, and it works in first out manner, and it is the one that sends the request to the CP. Okay, so whenever an interrupt is generated, whenever a key is pressed, okay, it is the one that sends the interrupt signal to the CP. And apart from that, we have this FIFO also has a status that shows the status when the buffer is available or when it becomes full or empty. And we have the display RAM control, and which is of the size 16 cross 8. Okay, and it stores the data to be displayed after processing. Okay, and each location it is able to store one display digit. And we have the display address registers. It holds the data before sending them to the recipient. So the output data, it drives the output lines. So these are all and the next is the return lines, that is RL0 to RL7, mainly to take control what is the input key that is pressed. Okay, and we have the output lines A0 to A3 and B0 to B3 that sends signal to display. Okay, so and then the display address register, and it is used in Intel to select the location in the RAM. Okay, so where the data will be written and or from which particular location the data will be read. So, and some of the applications of 8278 programmable chip, it is used to control the interface keyboard with the output device to sense what is the input that is provided. And we have the digital equipments, okay, and like the instruments that we play. And it is even used in the interface of a calculator, or even it is used in the embedded system. So these are all some of the applications of 8279 programmable chip.